Okay, Common Core Algebra 2. So we're starting section 2 now, where this is going to be broken into two parts. So the first part is going to be a review of properties of exponents. So we've talked about this before. We're going to review a few of them really quickly. And then we will extend that to properties of radicals, which have very similar properties. And then we'll talk about simplifying radicals. And you're going to see a key term like rationalize. Okay, so that isn't rationalize there. Alright, so that will be the key term for simplifying radicals. Okay, now, first thing, when we talk about properties of exponents, we have talked in the past about MADS, PM, where each one of these colors, remember, standing for something different. So the M and the A meant multiply and addition. And that meant when we multiply the bases, we add the exponents. So an example of that would be a simple one like x to the fourth times x to the third. So when we multiply our bases, our x's, we add our exponents, we get 7. Okay, the ds then is divide and subtract, and so it would be very similar. I could say y to the 9th over y to the 3rd. So here we're dividing our bases, y, so we're going to subtract our exponents. We'd end up with y to the 6th. Also remember, negative exponent means change position. And then the last one to keep in mind, the PM means if we have powers, we multiply. So power to a power, then we multiply those powers. So that would be something like z to the 4th to the 2nd. So in this case, we don't want to add those powers. We want to multiply them, and we'd end up with z to the 8th. Okay, so that's a quick review of several of our properties of exponents. The big one there that we didn't talk about was the negative exponent. Remember, that means you're going to write a fraction or a reciprocal, or you're going to change location. We've talked about it in each one of those ways. Okay, the properties of radicals. So you see we have two properties of radicals here. The first one, the product property of radicals. Basically what that means is if we are multiplying two things together and we're taking that nth root that we talked about, well, sometimes it benefits us to separate those. So we get to have the nth root of A times the nth root of B. Okay, now the other thing that might help is actually doing the reverse of that. So suppose I had something like the third root of 12 times the third root of 18. Now here, neither one of these really help us because there is no perfect cube root or third root of 12 or 18. But based on this rule, we could take the cube root of 12 times 18, and then if we simplify 12 times 18, we get 216, and the cube root of 216 does exist. That would be 6. So in this case, it benefited us to actually do the opposite of that rule. Instead of separating them into two things, we can put them back together as one, and sometimes that helps us for our cube root or whatever root we're taking. Okay, the quotient property is very similar, except for instead of multiplication, remember that quotient means division. So we would have the same basic idea, but now you see here instead of multiplication, we have division, and we can separate those into two things. Okay, again, I'm going to show you one kind of going backwards. If I take the fourth root of 80 over the fourth root of 5, well, there is no fourth root of 80, definitely no fourth root of 5, so that's difficult, but we can make the fourth root of the whole thing 80 over 5, and if we do that, then the fourth 80 over 5 simplifies to 16, and the fourth root of 16, if we use our calculators, we know that is going to give us 2. So you see there it benefited us to actually put them back together so that we could simplify to get 2. Okay, so that is your those are your two properties of radicals. And the last one is going to be simplifying radicals. And again, just as a reminder, we often call this rationalizing the denominator. Okay, so in order to simplify it, or to put it in simplest form, we're going to rationalize the denominator. What that means is there can be no perfect nth powers as factors. So like on the last one, you couldn't have the fourth root of 16 as some factor because that can be simplified to 2. So we need to figure out what each one of our radicals is and maybe break them down into factors so we can simplify as much as we can, kind of like we did with square roots earlier. And then number 2, the other one is that we can have no denominator that is unrationalized, meaning no radical of any root, no radical in the denominator. Okay, So a couple examples of that. We have the cube root of 135, which if we put this into our calculator would just give us some decimal. So we need to figure out, kind of like what we did with square roots earlier this year, we need to figure out 135 is a product of two numbers, one of which has to be a perfect cube. And I say perfect cube because that's a cube. If it had to be if this was a 4, it'd have to be a perfect fourth root or quartic. So I know that 135 is 27 times 5, which is nice because then I can use those rules we just talked about. I can split this into two things, and the cube root of 27 is 3. So we'd get 3 times the cube root of 5. So that is really rule number 1. No perfect nth powers as factor. Okay, the second one, then this is about rationalizing our denominator. So I'm going to take this, and I chose to multiply it. This is really 1 now, remember, because anything over itself is 1. But I chose the fifth root of 4 over the fifth root of 4 because that's going to give me a denominator that is a perfect fifth root. Okay, and so these can be hard to find sometimes until we find a perfect fifth root. We'll talk about how to decide on what to use in class for those. And so when we multiply those using that product rule again, we get the fifth root of 28 and the fifth root of 32. Well, the fifth root of 28, there's nothing we can do to that, but 32 is a perfect fifth root. In fact, it is equal to 2, and so now we will be done. Okay, the big point here is we want to get this root gone. And so now that we have a 2 in the denominator, that root is gone, and we have achieved rationalizing the denominator. Alright, so that is it for this lesson. We did a quick review of properties of exponents, which you remember is that MADS PM stuff. And then we looked at two properties of radicals, both the product and the quotient. Basically, it said we could split them through division or put them together through division, and also with multiplication. And then the last one, simplifying radicals, the one that tends to give us the most trouble there is when we have to rationalize that denominator. Alright, see you next time, guys.